All right, so welcome to today's webinar Wednesday on Rockwell 1694 electronic circuit protectors. My name is Chris Jones, and I am one of the industrial automation managers here at Shaler Yesco, and I am in charge of the intelligent device team. Your cameras and microphones are turned off to keep things running smoothly today. Please post any questions in the chat, and I'll be monitoring that as we go throughout, and then we'll get those answered for you here either during the presentation or afterwards. This training we are recording and we will post it online for future viewing. So if you know anybody that missed it, we will be sending a link out following today's presentation. With no further ado, I'd like to turn things over now to AJ Cronrath, one of our automation specialists here at Shaler Yesco, who will be hosting our seminar today. AJ.
Thank you, Chris. Good afternoon, everyone. Again, like Chris said, my name is AJ Cronrath. I'm going to be discussing for today's webinar Wednesday 1694 electronic circuit protection module. So this product has been out for a couple years now, but it's gaining a lot of traction within the industry, especially on the 24-volt DC side, which is what this is protection of. So I just want to go into depth about what this product is, what it can offer you, and how it can help you and in your industry as well. So what is this 1694? Well, 1694 is basically like a fuse. So as you can see here on our left-hand side, we have our power supply attached to fuse, and then from the fuse to our load. Obviously, if there's a short circuit or an overload issue, that fuse would blow, which everyone's pretty much aware of, but that's a one-time use only object. The 1694 is an electronic fuse. So it's basically the same thing, except for the fact that it has a little bit of a faster trip time, as well as the ability to reset any type of scenario that happens where there's an overload or a short circuit. So as you can see on the right, we have where the fuse would be is where we would put our 1694 PM or protection modules in there to protect our load that's down the line. Now, how are we going to do this? How does this all work? Well, there's a backplane that they sit in the back there, or a backbone is what we call it. And this backbone here has pins that are attached to it, and each of these pins show or have a job to do within the 1694 modules. So as you can see here, we have a communication pin up there for talking between the different modules there, as well as our 24-volt DC line to run power from our power feed module down the line to our protection modules going down through. So how does this attach to each one of these units? Well, if you look at a top view of these two matched together, you can see where that backbone sits open. And as you can tell here, when they mesh up together next to each other, they will then attach by pushing that backbone in, and it clips the two modules together. So once the modules are clipped together, as you can see here on our right side is that top view there with the backbone closed, then those modules are connected together. And so because they're connected together there, they can distribute communication as well as power back and forth between each other. So it's kind of like what you would have on a PLC when you have your backplane and you're attaching your I/O to that. This is the same kind of version, just a smaller version of this. Now, as you can see here on the left, you're going to see a 1694 PFA or a PF, which is our power feed module. They do not have a backbone. And the reason why is that is where your incoming power is going to go into. Now, we'll discuss that further down the line, but they will not have one. And that is the beginning of your power feed module. So when you set these up, you start with the power feed and work your way down through because you have to start at that starting point there. Yeah, I had to type in the chat.
I got my hand up, AJ. Can you see?
Yes.
So question I have is, you talked about them being able to be reset. Would that be over the communications, or would someone physically have to do that?
Well, we'll discuss in both. So it's actually both. You can actually physically do it at the location site using the LED buttons that are on top, or when we talk about IO link, this can be remotely done. Hopefully that answered your question. Okay.
It does.
What was that? He's good? Okay, cool. So going on to here, how do we install these? So when we go to install these, they ride on a DIN rail, just like you would use your regular 1492 terminal blocks, but they're not quite the same. So once they lock in, they lock in. They do not slide up and down. So it's not one where you're gonna try to slide it down or move things back and forth. So when you go to set these up, you want to make sure you have an area to put these into. They clip from the back to the front. And once they clip into place, they lock themselves in there. So it is very important that when you clip these modules in place, that you make sure that you're clipping them right next to the next module so that those backbones line up. So when you press that backbone in, then you make a positive connection on that. It's just a little reminder for anybody that's going to be installing these. So we did have a little bit of a conversation about some of the modules here, but let's go in a little bit of more detail with those. And the detail here is this is how a typical setup would look like. You have your 16, and we'll start at the top left, our 1694 PF, which is where you would start, which is your power feed module. Again, that's where a 24-volt DC power is connected to. Maximum current is going to be 40 amps, so we cannot go over 40 amps running to this power feed module. It starts on the leftmost side, and then it feeds the rest going to the right. Moving down to the lower left, you're going to see your protection modules, your 1694 PMs. Your PMs are where you're going to have your circuit protection at. So that's where all your circuit protection is coming from. That's where your sensors, any motors, they're all going to be running in through there. They come in a variety of different options. You can either do one channel, which if you look in the middle there, they have that 10 amp one channel, or you can do a two channel, which if you look at the first module or the third module, they have two channels going in there. They can be fixed at a variety of amperages, no more than 10 amps per channel can be utilized there. And also remember, every time you add these, or putting in a module, you're adding up all that amperage. So you can't go over 40. So if you have two dual channel 10 amp modules, you're at your max capacity currently. So you can't add anything else to it. You're going to have to add another power feed module and run another line into there. You cannot continue to move forward. So that's a good reminder of just remembering when you start stacking these, you can't go over that 40 amp, the 40 amp threshold that we have there. Next to those power feed modules, next to the protection modules, you're going to have your 1694 DM or your distribution module. So your distribution module is going to be where maybe you want to send more power out, or you don't need protection on it, but you just want to hook up a sensor or a light or whatever it is. That's what's going to come from your distribution module. So that's where your 24 volts coming out is going to go, as well as your ground to any of the multiple other loads that you would have there. This is also your ability to run from one panel to another. So let's say, which is a good feature here, is let's say I have two panels next to each other. I don't have to have two power supplies. I can run one power supply into this power feed module, go from a distribution module into the next panel. From that next panel, I can run my other PM modules, my protection modules in there, again, as long as it doesn't add up over 40 amps. So that's just a key reminder, just don't add up over 40 amps. So it gives you a little variety on space saving, not having power supplies everywhere, and being able to distribute this power out to any of your products that are sitting out on the line or out within your factory floor. So we talked about how to set them up, what the backbone looks like. We also talked about the different modules that this come with. So how do we put this all together? Well, standard application for this will be something like we have here, where we have our circuit breaker, circuit protection leading into our 1606 power supply. From our power supply, we're going to run into, again, our 1694 PF or power feed module. Again, making sure we don't go over 40 amps there. Power feed module, and then right next to that power feed module is going to be where we're going to do our 1694 PM or protection modules. From there, as you guys can see here in the middle of the screen, we have our protection modules that are then running out to our different there's a motor here. Maybe we have a couple sensors sitting out here. But whatever we're looking to protect, it runs off of those protection modules out into the environment that we need it at. And then next to that, as you can see here, is a 1694 DM or distribution module, which can feed into another cabinet. As you can see there, they're showing an additional cabinet going over there. You can run there, or you can run your power supply, another line over to that other cabinet as well. Either way works. Or you can just run that out to additional items that need 24 volts DC. So, you know, it saves you with a lot of wiring, a lot of extra wiring needed. And a lot more home runs that are needed. So it's a very space saving and as well as efficient designed model. So why would we want to use something like this? Is it just because it looks good? Yes, but it's also because it provides some type of protection. So what are those key features for it? Well, a couple things is number one is our time saving for our push-in terminal. So a lot of that's been hitting the industry big time here. Back when I was a maintenance guy and worked in the maintenance field, screw terminals were a big thing, but then you always had to have a PM to go back and double check them because of vibration or anything like that. So we can take that out by doing these push-in terminals that give you a more positive connection that is not it's not hurt with the vibrations, right? So it doesn't have to worry about a lot of the vibrations that you would with a screw terminal. So that's one of the benefits. The other thing is the LEDs that are on there, they're diagnostic lights. They're green, amber, and red, and we're going to go into a little bit of what that looks like. But it's a good visual diagnostic, especially for troubleshooting. When you're having issues with a motor or a sensor or something going on, you don't have to have your meter going all the way out into the panel, then going out to the sensor itself. You can see visually opening up the panel, the maintenance guy, personnel, or whoever's looking at it can see, hey, here's a trouble spot. Let me go look at where it's at. And it kind of reduces the amount of downtime or troubleshooting that's needed to be done with these. The other thing is as we discussed before, it's a built-in micro switch, is a manual on and off as well as reset. So each of these buttons, you can either turn on and off the product that you have it attached to, or if it does go into a trip scenario, once you fix it, you can reset it right then and there. So it's a good little feature. Now, what are these lights? What do these lights mean? Well, the LED lights give you a great visual indication of what is happening out on the floor. So the one application would be the green LEDs. So your green LED light is going to tell you that loads are connected and everything is good to go. We don't have a problem. Everything's running smooth. If we have a green and amber blinking LED, as you can see in the upper right side there, that's telling us we're at a 90% load capacity. So we're getting to the point where we're getting into an overcurrent state, and it's warning you that there's something going on here. So this is a great option for visualization for a maintenance guy to say, hey, there's a problem here. I need to cut it off before it shuts the machine down. This is a great opportunity for maintenance guys to be able to see what's actually going on in the field without having to take their meters out there. Now, again, when we talk about IO link, which we're going to talk about in the future, these thresholds can be set within your control tree and on the AOP. And that allows you then to even send a warning to whoever needs to be sent the warning to when this becomes a problem. So if something's getting to that 90% threshold or a threshold that you're going to set within the PLC, then you can send a fault or a warning signal out to whoever needs to know what's going on. In the lower left, you're going to see non-illuminated means that it's either turned off or there's nothing attached to it. So there's nothing being run from that unit or that piece of equipment is turned off. And a red indicator is telling you that the device is tripped, whether that's a short circuit or an overload. It is tripped there, and that can be reset at that location there. So we talked about the LED lights. We talked about the functionalities of what they look like. Let's talk about versatility. So what's really nice with the 1694s is that, as you can see here, these are a little bit different protection modules. They're labeled 1 through 10, so 1-10 amp. Well, that's because we can set these depending on what we want. So again, maybe we don't know at that time what we're going to set this at, or maybe it's versatility. We're changing them here and there. Each one of these can be set in a certain way. So I have actually a video here that's going to show you how do you read this. in the current readout, and then how do you change the setting within the current setting. So I'm hoping this works. Let's keep our fingers crossed. So yep, it'll work. So here you can see the current readout. The guy's going to press it there. It's going to blink, and then he's going to count the number of blinks. So you're going to see here that the number of blinks comes to 10. So what's that telling him before it goes to the amber? It's telling him that that is set at 10 amps. So that is currently set. That channel there is set at 10 amps. So it's letting him know that that's what that's set at. Now, how about we want to go and change that? So when we go to change it, what we're going to do is we're going to hold it for a little bit of a longer time frame. As you can see, he's holding it, and it goes into this mode of our set mode. Now, what you're going to do here is you can see that the lights blink slower. You're going to count the number of blinks you want, and then you're going to press the button. So you're going to see here, when it comes back around, he's going to set it for 3 blinks. So here he's going to count 1, 2, 3. He presses it. It now stops. He now is going to check it to verify that that's the case. 1 click. Once it switches over, 1, 2, 3, goes to red. You can see now he went from 10 amps and switched it to 3 amps. So it's that quick and easy, can be done out on the field. And again, that can even be done faster, obviously, once you have IO Link and we have it back into the control tree. So it's a great little feature in case you're swapping out motors, or in case you're changing something around, or line change, or whatever's going on, and you need that versatility. That versatility is sitting there right there for them. So now we've had a couple of different conversations about IO Link. So let's dive into that. Now, IO Link, as some of you know, is the ability to pull a lot more data and information out of what we used to call dumb sensors. So a sensor just sitting out in the area, is just sitting out there, not doing anything. How do we get stuff? We get vibration analysis from some of the sensors now. We can get temperatures from some of the sensors now, which is a great opportunity. We can also tag all those items back into the control tree. So we don't have to be physically there. We can monitor that from a separate location. So, and that's where IO Link comes from. So if you guys remember, we went back there and we were all the way back and we were talking about the different modules. We had our 1694 PF and we had our 1694 PM. So the PF module, when you add the D to it, so it becomes a PFD or a PMD, that dictates that it is an IO Link module. So it has to have that D on there. Otherwise, it's not an IO Link module. And the reason why is if you look into the lower left side here, you will see that the 1694 PM and there's a 1694 PMD backbone. The PMD backbone has an ADDR pin. That ADDR pin is what does the communication for IO Link. So if that pin does not exist, then this cannot communicate through IO Link. So it is very important that you look at, if you're going to do IO Link, that you have the PMDs or you have the D modules, one with the D on the end. So it has this ADDR pin attached to it. So going through here, as you can see with the power feed, the IO Link, you can see where it has the connection, right? And that connection there will go out to our IO Link master. So you will need an IO Link master attached to this. And then as you have our PMD module set there, they're now going to communicate all the way back through the IO Link master back to the PLC and into your control tree. And from there, you can remotely monitor any of the modules that you have currently attached to this. So whether that, if it's a trip scenario, this is our short circuit scenario, how many amps are running through it, maybe you're changing the thresholds with it, I want to do a reset, maybe I want to turn something off. All that can now be done remotely so that you don't have to physically be in front of these modules. Again, some of those key features I just mentioned there was we can set up thresholds, as you can see here, the load current monitoring there in the middle, looking at the faceplate, and we're looking at what everything's looked like and setting our thresholds and our values. You can also do the remote reset and on and off from remotely, kind of what we just pretty much talked about on there. Now, how would this look? What does this kind of situation look like? It's obviously not going to be set up the same way as we did the non-IO Link module. So a typical application for this would be something like this, where we have a PLC compact logics. It's going to be attached through an Ethernet cable to our 1734 IO Link master. And then from there is that 3-wire cable that we saw in the previous slide going into our IO Link assembly for our 1694. And that is as easy as it gets, crystal clear, simple as pie. Right there is the way it would be set up. And then obviously then you're setting your data back and forth between the PLC and your IO and your 1694, and then obviously using Studio 5000 you can monitor this remotely. So it's very slick and an easy way to set this up for remote monitoring. Sorry. So recap real quick. We talked about that backbone and how the communication and setup is. We've discussed multiple times it's 40 amps max for these. We also require that this is 24 volt DC. We discussed our power feed modules. We discussed our protection modules and our distribution modules. All right. Now, why would we want to do all this? Oh, I forgot. We also had the IO link, so we can do remote as well as at the panel. We can change. We can reset. We can turn on and off. We have visualization. We have all those nice items. But why would we want to do this? Why would we want to spend the time to do something like this? Well, that's because of a nice little thing called NEC Class 2. So NEC Class 2, for those that you don't know, is a regulation for low voltage DC circuits, and it maximizes the amount of voltage that is allowed through the wires in a DC circuit. So it reduces electric shock as well as fire hazards by limiting it to 100 VA. Now you might come back and say, AJ, well, my power supply does that. Well, not all power supplies do that, and even power supplies that say that they have an output rating of 100 VA are not Class 2 rated. They have to have the UL certification attached to them. So even some of our 1606 power supplies that we sell here at with Rockwell, some of them are not Class 2 rated. So you got to make sure that they say Class 2 on the side there. Now, why would we want to bring in then these modules? Why not just change my power supply? Well, maybe you don't want to do that. Maybe you want to apply multiple protection to multiple different units. And again, this is where these 1694s come in. And the fact that, as you see down at the bottom, it says, if the circuit protector is NEC Class 2 rated, then you don't need a Class 2 rated power supply. So this is where 1694s really come into play here, because they are Class 2 rated, NEC Class 2 rated, every single one of them. And so they provide that protection for that NEC Class 2 that is needed in a 24 volt DC circuit. So again, some of you are probably saying, well, how do I know if I need it? Well, you need it by knowing what's connected to your DC circuit. So a lot of the products that we have here, as you can see on the screen right now, are Class 2 source required. And they will say that on the side of the product. So some of them will say that they require a Class 2 rated either power supply or some kind of circuit protection necessary for them. So make sure that when you're out there, again, that if it is requiring a Class 2 source required, that you do have a Class 2 power supply, or that you have some kind of these protection modules here, or some kind of protection module that is Class 2 rated that will allow you to then protect these modules that are these products that are out there on your floor. So how would this setup look like? So what would a Class 2 setup look like? Again, right here is what it would look like. Here is you would have an existing power supply, again, 5, 10, 20, or 40 amps. Again, no more than 40 amps. And that's going to run down to your, as you can see here, we're tapping off of that 24 volt line there for our PLC, for our HMI, and it looks like for a Kinetics drive sitting there. And then we're going to drop that into our 1694 module. And that is going to give us our Class 2 approved protection for our sensors and components that are out on the plant floor. So that gives us that rating that is necessary, and then we're well in with compliance with everything that we need.
AJ?
So again, I hope everybody got something out of this. I know it was a lot to digest, but 1694s are a really good little module to have here. They're little more than just a simple fuse. But again, they provide a lot of versatility and variety, not only within panel space and creating more panel space, but also for maintenance and troubleshooting and being efficient with keeping our machine uptime running. So I'm going to look and see if there's any, well, actually I'll ask Chris if there's any questions or anything like that. So
Yeah, so it looks like there's one here from Tony. What year did this come into effect and in what states? I imagine, Tony, you're talking about the NEC Class 2 when you asked that question.
Yes, sir, that is correct.
Yeah, so NEC is a North American standard. So when you
It
say
is.
what states, that is
Yep.
all for
So
North America. I
The
don't
fun
know
part
the
about
year.
that, is that Chris?
Yeah,
So the fun part about what you're saying is the NEC is approved by each governor in each state before it goes into actual effect. So I do work in Pennsylvania and in Virginia and in Tennessee, and Illinois. That's why I ask what states that particular code has been approved.
yeah, that's a great question. All I know, what I can tell you right now is that it's North American, which is in line with the IEC and European standards as well. That's something I can definitely find out for you, Tony, and let you know.
Yeah, if you could at least let me know what your code book that came out in, that would be a good start.
Sure. Yeah, I mean, what I know is, NEC defines a class 2 in Article 725, 121. So, that's where they define it. I don't
Can
know,
Put
which
those
states
numbers in the chat, Chris.
Yes, absolutely. Any other?
any other questions? All right. If not, thank you for attending today. If you'd like more information on the topic or have any additional questions, please reach out to our sales rep, or you can email us at info@syds.com. If everyone's good, you guys can all have a great rest of your day, and thank you for showing up. I appreciate your time.
Thank you very much.